Alright, this time, let's do the collector game. The goal here is for the drone to collect only the green balls, and not run into the red ball. It has no distance sensing device or anything, but it does have a camera, and it can see the environment. It can see the green balls and red balls. So, we need to write a program to do the image processing, so that the drone searches out the green ball but avoids running into the red ball. If you click on the drone, you can see the various codes that you can use in the program. And this is the camera frame code you can use to access the camera view. Okay, I'll go over briefly on the program codes to control the drone. You'll need to understand a little bit about the Numpy arrays in order to write this program. But not much. I'll go over it very briefly so you'll get the general idea. Okay. So, this first line imports everything from PyJop library. And you also need to import the Numpy library, because we'll need to use the Numpy arrays. This line connects the code to the simulation environment, in order for the code to interact with it. This selects the first simulation environment available. This resets the environment to initial state. And this selects the first drone available to be controlled by the code. So, now we come to the image processing logics. This line captures the current image from the drone camera and store in the variable image. And these lines here consist of the logics of the image processing. And this next line uses the Numpy array, image, to capture all the pixels on the camera screen, and searches for the green color pixels. This colon symbol in the first position means you want to include all the rows in the image. And this colon symbol in the second position means you want to include every columns in the image screen, therefore, you want to capture the entire screen pixels. And the number 1 here means you want to search for the green color, remembering that RGB color where red is 0, green is 1, and blue is 2. And you want green at the highest intensity, which is 256. The lower the number, the dimmer the intensity. This next line does the same as the previous line, except it captures the red pixels in the image frame. This next line masks out any mixture of green and red color pixels, such as when red and green balls are behind, or right next to each other, and cause the drone to misidentify a red ball as green. This next line compresses the image vertically, resulting in a 1x256 pixel array where each element corresponds to whether any green pixels exist in that particular column. The element is true if there is a green color in that column, otherwise, it is given a value of false. The purpose of this 1x256 array is so that it is easier to detect horizontally left or right where the green ball is. This next section, the if statement loop does the following function. If no green pixels are detected in the 1x256 array, the drone will continue rotating via the thruster actions until the camera detects green pixels. And, if it does, find green pixels, this next line will store the column position numbers of the green pixels, and the variable green pixel indices as a tuple. Here, I give a simplified example with column number 120, 150, 170, and 190. These will be stored as tuples in the green pixel indices variable. The next thing we need to do is to find the average center position of the green ball. And we do that by taking the mean, or average value of the green pixels indices. That will tell us the approximate center position of the green ball. And, store that value in the variable, centroid. Centroid is the approximate center position of the green ball. Well, that was a lot of image processing just to figure out where the green ball is. We're almost finished. Now we need to control the thrusters of the droid and point it toward the green balls. That's what the next line does. It first calculates the deviation of the ball from the midpoint of the image screen, which is column 128, since the width of the screen image is 256 pixels. And given this deviation of plus or minus value, we know if the ball is left or right of center. And we use this deviation value to control the thrust amount on the left or right. And that is accomplished by these two lines of codes. And all these codes sits inside the while loop, which continuously updates the image, the ball location, and the thrust adjustments. And, finally, this last line disconnects the sim environment. So, let's run the entire program and see it works. Here, the drone found its first green ball. Now, it is rotating to find a green ball. And it found one. And it found another one. But it is not chasing after the red ball. It actually sees two green balls. And it will go to the closest one. Here, I will speed it up to save time. And, that is it. See you in the next video. Bye.